Okay, let's talk about some more past paper questions related to trigonometry. But you guys will get to see that when we talk about past papers related to trigonometry, we get to practice the previous topics as well, right? So this is the best thing about doing past papers. Okay. All right, so this is basically the second part of a question. I'll tell you the paper number and everything. I have that not on this PDF, but on my phone. The question says the function f of x, that is 3 cos squared x minus 2 sine squared x, is defined for this domain. Okay. Express f of x in the form a cos square x plus b, where a and b are constants. So you can think about this 1 mark question as a trigonometric identity question. You need to prove something. You need to show that this thing is basically equal to this thing. And how do we do that? Using our helping identities. So let's write down the first thing. F of x is basically 3 cos squared x minus 2 sine squared x. Now, what do I see? I can see that I need to convert it in such a way that I get rid of sine squared x. I only have cos squared x. So what identity should I use for this? Can anyone tell me?
1 minus cos.
Yes, that is right. Very good. Okay, so basically, originally the identity is sine squared x plus cos squared x equals 1. Okay, Mutasam, these are basically helping identities. This one, sine squared x plus cos squared x equals 1, is a helping identity that we use in order to prove things. Okay, this is something that you need to keep in your mind directly. I did not say this by myself. You need to memorize this and then use it. So what I can do is I can just make sine squared x the subject, and I would get 1 minus cos squared x. And now I can just plug in this value. So 3 cos squared x would come directly, minus 2 multiplied by, instead of sine squared x, I am going to write this down, 1 minus cos square x. This would give me 3 cos squared x. Minus 2 into 1 would be minus 2. Minus 2 into this would be plus 2 into cos squared x. Next, I am supposed to add this in this because these terms are same. This is going to give me 5 cos squared x minus 2, and this is the answer. So this implies A is 5 and B is minus 2. You're not supposed to write down the values of A and B. This is something that I just do every time to explain this concept. Okay. So this was a question where you had to prove some sort of identities or convert one trigonometric expression to an equivalent form but a different representation, and we got that representation using our helping identity, sine squared x plus cos squared x equals 1. Okay, this is how we prove trigonometric identities. Any confusions, Rafe, Motasam, and Munja?
No, miss.
No.
Okay, Motasam?
No, miss.
Okay.
No.
Okay, perfect. Okay. All right, you can mute your mic now. Right, so this is basically the next question, and it says, given that x is greater than 0, find the two smallest values of x in radians for which this 3 tan and the angle is 2x plus 1 equals 1 holds. Show all necessary working. Okay, so it's very simple. Okay, the question has been made very, very complicated by using difficult terms and all of that, but it's just a trigonometric equation, And instead of 1 theta, like you don't have theta, you don't have x, you have this entire thing. You have 2x plus 1. So you need to consider that as theta, okay? And once you have your theta, then you can always find the value of 2x plus 1. Let me explain this to you properly. Okay, what we can do is, let's do it directly. I need to find two smallest values of x. Okay, now x is the variable of the equation. So if I am to find two smallest values of x, I am basically trying to solve the equation. So it is 3 tan 2x plus 1 equals 1. This is basically your trigonometric equation that you need to solve. How do we solve trigonometric equations? That's simple. I need to make tan the subject, okay? So I'll just take this 3 on the other side and it would become tan 2x plus 1 equals 1 by 3. Okay, this is tan. Okay, next. I'll take tan on the other side and this would give me 2x plus 1 equals, it would become tan inverse of 1 by 3. Okay, so at this point, either you can replace this entire thing with theta or you can directly consider this the theta. That's also fine. Okay, next, I need to talk about quadrants because tan was basically equal to 1 by 3 even before this step. Let's write it down this way. So tan is basically equal to 1 by 3, right? We do this thing on our calculators, but while discussing, we are always used to writing it down as positive fraction, negative fraction, or 0. So tan is positive. When is tan positive? In which quadrant? Can anyone tell me?
First and third.
Very good. Okay. So it's all positive. It's sign positive. It's tan positive. And it's cos positive. So tan is positive in the first and third quadrant. Okay, how do we find angles in first and third quadrant? So let's talk about that as well. So first of all, I would find this alpha. Once we have this alpha, my angle in the first quadrant is going to be this one, alpha directly. And in the third quadrant, it would be all the way from here to here. Okay. All right, so let's use our calculators and make sure that since it has been clearly mentioned, you need to give your answer in radians. Now your calculators must be in radians mode, okay? Do not try finding it out in degrees and then converting it to radians. There's no point in doing that. So tan inverse 1 divided by 3. And this is going to give you 0.321 radians. Okay, now the 0.321 radians is what? This is the value of 2x plus 1, whatever you have over here. Usually we have theta here, or usually we have one variable here. This time around we have 2x plus 1. That's fine. Okay, so 2x plus 1 is basically equal to 0.321. This is the first value. And can anyone tell me what would be the value in the third quadrant? What is the formula for third quadrant? So it would be, now we're talking in radians, okay? So it would be pi plus 0.321 radians. Usually for the third quadrant, it is 180 degrees plus alpha, okay? But we're talking in radians. So 180 can be written as pi plus whatever you got as your alpha. Okay. So this is, yes, 3.4. 4, 6, 3. Okay, I'm just writing it down to 3 decimal places. Any confusions with this?
No, miss.
Okay, now we are not done yet. We were asked to give the values of x, not 2x plus 1. Okay, so finally, you know that 2x plus 1 is equal to 0.321. This is your first equation. And you know that 2x plus 1 is equal to 3.463. Please quickly work out the values of x. That's very simple. I want 3 answers. Yes, please tell me the values of x quickly.
Miss, the first one is negative 0.3395.
Yes, okay, very good. 1 second. It's negative 0.3395. Okay. And
1.213. And we will take the answer as 1.213.
yes, 1.2. 1 second. It's 3 point because it's slightly different from the marking scheme. So and it will be divided by 2. Yes, it's basically 1.2315, right? This is what I'm getting on my calculator. Okay, just do this again and you would get the same answer. It's 1.2315. Okay, and obviously we need to consider one answer, that is the positive answer, because this was clearly mentioned. Very good, Rafe. So x is going to be 1.23 and this is the answer. You can also write down radians in front of that, but it's equally good. Okay, yes, this is fine. Any confusions with this?
Miss, we are meant to write
Miss,
the answer in 3 significant figures, right?
Yes, 3 significant
Right.
figures. Yes, that's correct.
Miss, the other answer is negative, so we can't consider negative, right?
Yes, not because of some rule. No, there's no rule about negative values. It's just this, that in the beginning of the question, it was mentioned that
It's
given
more than
that,
0.
yes, that's why. Very good.
Okay, thank you, Miss.
You're welcome. Munja, anything that you would like to ask?
No, ma'am, I'm okay.
Okay. All right, okay. Acha, I'll just read it. Try doing it. I'm right here, and then we will do it together, okay? It says, show that the equation 3 cos to the power 4 theta plus 4 sine square theta minus 3 equals 0 can be expressed as this. It's simple, okay? Where x is equal to cos square theta. Okay, this is basically your question. You're only supposed to use one helping identity and this substitution, and then you can easily write this thing as this. I'll write the both the helping identities for those who are not used to them for now. So the first one is sine square x plus cos square x is equal to 1, and tan theta is equal to sine theta by cos theta. These are your two helping identities, and only these are important for AS. Yes, all of you can do that. It has nothing to do with previous knowledge. Nothing to do with previous knowledge. Okay, everything is written right in front of you.
Miss After.
Okay, perfect. Very good. Okay. So, Motusam and Munja, are you guys able to process this?
Miss, until then, can you tell me the papers?
Yes, yes,
All the
yes, definitely. So, it's this one.
this is B part 1 or what?
Yeah, 1 second. This is 7 part 1. Okay. The
So
question
7
that
part
we
1,
were doing right now. Yes.
13, 14. And Miss, what about the previous?
Yes. So the previous one was this question, part A, and this was the exam. Very good, Munja. Motusam, are you done with this question?
Miss, and the B part 1.
Yes, 1 second. That I need to check. 1 second. Okay, it is the same paper. Yeah, it is the same paper, but I am not sure about the question number. But it is the same paper, like this paper.
Okay, Miss.
970912 October November 19. Yes, okay. Motusam, are you done? Were you able to prove this? Okay. All right. Okay. Let's see how exactly are we supposed to do this question. Okay. It says, show that this thing can be expressed as that thing. Okay. So when I look at the given substitution, let's try directly plugging in values. I can see that 3 cos to the power 4 can be written as x squared plus, now what do? I don't have anything for sine square theta, right? So I need to replace the sine square theta with cos square theta. And how do I do this replacement? I'll do this replacement using this thing. So 4 multiplied by, instead of sine square theta, I am going to write 1 minus cos square theta. And this would give me 1 minus cos square theta is basically equal to x minus 3 equals 0. So 3x squared plus 4 minus 4x minus 3 equals 0. And finally, 3x squared minus 4x plus 1 equals 0. So this is the answer and this has been proved. Okay. So always remember, do not think in any other direction. Every time these two identities would be used. Yes, not directly, but indirectly. Yes. Okay. So you guys would be using them every time. Okay. Very good. Both of you were able to do it. Let's see. Let's talk about the next part of the question. Now it's a 5-mark question. It's important. Okay. Acha. Now it says hence. solve the equation. So whenever the examiner would say hence, forget about this part. Just quickly go back to the previous part and see why exactly is he saying hence. Okay. So hence is being used because this thing can be written as this thing, right? So I can solve that. I can solve 3x squared minus 4x plus 1. 3x squared minus 4x plus 1 equals 0. This can be solved, and the substitution was that x is equal to cos square theta, because at the end when the examiner is saying solve the equation and when the equation has theta as your variable, you need to make sure that you only find the values of theta at the end. Okay, he's not interested in x, he's interested in theta. Okay, all right, so let's quickly just solve this. So you're only supposed to solve this trigonometric quadratic equation. It's simple. Two numbers such that when you multiply them you get 3x squared, and when you add them you get minus 4x. So it would be 3x squared minus 3x minus x plus 1 equals 0. I can take 3x common, it would give me x minus 1, and I can take minus 1 common, and this would give me x minus 1 equals 0. So finally the two factors would be x minus 1, 3x minus 1 and x minus 1 equals 0. And this would imply that x is equal to 1 by 3 and x is equal to 1. Okay. And since this was the idea from the beginning, x was equal to cos square theta. So I am supposed to write it down this way. Cos square theta is equal to 1 by 3, and then cos square theta is equal to 1. All right. Next, cos theta is equal to plus minus root 1 by 3, and cos theta is equal to plus minus 1. Now, why was it a 5-mark question? It was a 5-mark question because at this point you have 4 different equations and you need to analyze all these 4 equations, each equation through quadrants basically, right? So let me write down all the equations clearly. It's cos theta equals root 1 by 3, then negative root 1 by 3. This is the first equation. This is the second equation. The third equation is cos theta equals 1. And the fourth equation is cos theta equals minus 1. Okay, this is the fourth equation. So I'll help you with the first one, then you guys will do the second one, then I'll help you with the third one, and you guys will do it for the fourth one. So please pay attention at this point. Okay, I can see that cos theta is positive. Okay, now cos theta is positive. Let me make the quadrant here. When is cos theta positive? So it's all positive, it's sine positive, it's tan positive, and it is cos positive. Okay, cos is positive in the first quadrant and cos is positive in the fourth quadrant. Forget this in the beginning, do not look at it. Find all the thetas and then just write down those who are lying in the range, but initially find all the thetas. Okay, so for the first quadrant it would be alpha, and for the fourth quadrant this is alpha. And how do we find the angle? So for the first quadrant it's this one, and for the fourth quadrant we go all the way from there till here, and this is how we do it. Okay, so let's do some working to find out alpha. Now your calculators would be in radians mode because the previous calculation was in radians. This time around the interval is given in degrees. So step 1 is to convert your calculators to degrees mode. Okay, then cos inverse root 1 divided by 3, and this is going to give you 54.74. So this is 54.74 degrees. Okay, and alpha is same everywhere within one quadrant. If that alpha is this, it is also 54.74 degrees. Both of these alphas are same. So for the first quadrant, the angle would be 54.7 degrees. For the fourth quadrant, how do we find it out? Sum of angles in a circle is 360. So 360 minus this alpha would give you this angle right here, and that is going to be 305.3 degrees. I am supposed to write it down for now, and then we will just cancel it out looking at the interval. Okay, all right, this was the first equation. Now I want you guys to consider the second equation yourselves and then tell me your thetas. Okay, the basic angle, I'm just helping those who are looking at it for the first time. Again, when you will do cos inverse root 1 by 3, basic angle would be same. Using this negative, you are only supposed to change your quadrants. This time around, you would be dealing with the second and the third quadrants. Okay, so I am going to erase this and I will wait for you guys. I want 3 answers and I will wait. Yes, Modusam, please do this one. The second equation.
Yeah, I send the answer.
Okay, wait 1 second. Let me check.
Here on Zoom.
Yeah, just send me on WhatsApp because I think I've probably sent that to be on the other account.
Okay.
Mutasam and Rafe, are you done? Okay, very good. That's correct. Sorry?
Miss, I'm saying no.
Okay, so sorry. Take your time. So you're supposed to do for the second equation only, okay? Not for the third and fourth, only the second equation.
Miss, I've done the second one.
Okay, very good. Okay. So for the second one, the basic angle was same. Motasam, are you there?
Yes, miss, I'm here.
Okay, all right. Are you able to understand all of this now?
No, miss, I'm not sure.
Okay, now please pay attention because you have already told me that you did not attend the previous classes. That's fine, but still try getting some idea from here. Then I'll share the recordings. Okay, don't worry. Look at the second equation.
Okay.
Okay, it's cos theta equals negative. Cos theta is negative. Whenever cos theta is positive or negative, or sine or tan is positive or negative, we refer to these quadrants right here. Okay, cos is negative. Look at the four quadrants. This is the first quadrant. It says all positive. All positive means sine, cos, tan are positive. So we cannot do or stay in the first quadrant. Let's consider the second quadrant. In the second quadrant, it says sine is positive. So when sine is positive, cos and tan are negative. This means that we would be staying in the second quadrant, and in the third quadrant, it says tan is positive. So when tan is positive, sine and cos are negative. Again, cos is negative. So our required quadrants are second and third, because in the fourth quadrant, again, cos is positive, and here we have negative cos. Cos is negative, okay? The next
So we
thing
can.
is, yes. The next thing is, how do we find the angle in the second and third quadrant? So this is alpha, and this is also alpha. Like the value of alpha does not change, like when we are staying within one equation, okay? So when you will do cos inverse, even if you have negative, just skip this negative and do cos inverse root 1 by 3. That is going to give you alpha, and that is the same as the previous equation. Okay, we want angle in the second quadrant, so I'll start from here, I'll stop at this point, and this alpha is again 54.74. So sum of angles on straight line is 180. I'll do 180 minus 54.
Minus 59. Oh, this is 50, okay.
54.74. Very good. Yes, that's perfect. Okay, and this is going to give you 125.3 degrees, and yeah, let's write it down this way. And if you look at the angle at third quadrant, we start from here, we go all the way like this, and we stop at this point. Again, your alpha is 54.74. Can you tell me how would we find this angle? Again, the same basic rules of trigonometry. So we have a straight line, that is 180 plus alpha. And alpha was 54.74, okay? And this is
Yes.
going to give you 234.7 degrees, okay? Acha, this was
Miss,
all,
miss, I have a
yes?
question.
Mhm.
Miss, do all alphas have the same value?
Yes, yes. Whenever you're staying within one equation, right? Like when we were dealing with this equation, alpha was 54.74. When we were dealing with this equation, again, alpha was 54.74. But now when I will talk about the third equation, you will see my alpha would change automatically. Let's just quickly do this one. So I am going to erase everything for now. Yeah, not this, that is fixed. And there's a helping word for this, helping line. So it's add sugar to cups. Okay, so all sine, tan, cos, and they are positive. Okay, anyways, the third equation, cos theta is equal to 1. Cos theta is positive. In which quadrants exactly cos is positive? The first one says all positive, so it is the first quadrant. The second one says only
The fourth
sine is
one.
positive. Very good. And the fourth one, well done. Okay. So for the fourth one, again, I'm quickly going to make this line. This is again alpha. Alpha does not change. What is the value of alpha? We will do cos inverse 1. And this is 0. This is 0. Okay. So this value of alpha has turned out to be 0 degrees. So technically the line would be just lying on the x-axis, but that is fine. Just consider whatever you're getting. That's 0 degrees. And because for now we are just learning the process, okay? And for the fourth quadrant, I'll start from here. I'll go all the way from here to here, and this is going to be 360 minus alpha, and that is 0. So this is going to give me 0 degrees because first quadrant was valid, and in the first quadrant it was 0 degrees, and in the fourth quadrant it is 360 degrees. And when your cos is negative, again, the only difference in third and fourth is of sign. So basic angle or alpha is again 0 degrees. Just because of this negative sign, I am going to consider the second and third quadrants because cos is negative in second and third quadrants. How do I find angle in second quadrant? This is my line. This is alpha. And in the second quadrant, I start from here and I go till here. So it would be 180 minus alpha. Alpha is 0. So it is going to be 180 degrees. And for the third quadrant, this is the line. The alpha is going to be same. How do we find angle in the third quadrant? I'll start from here all the way there and I'll stop at this point. So it would be 180 plus alpha, and that again is going to be 180. So there's no point in writing 182 times, right? Or even you can write it down for now. Okay. These are all my thetas. Okay. Now at this point, I need to see that what exactly was my interval. Okay, I am telling you guys to find thetas first because every time you would not get this interval for theta. We just did one question where you did not have theta. Instead of theta we had 2x plus 1. So make this a practice. Some students just look at 0 to 180 degrees, they only consider first two quadrants. That is not the right practice because you would have to act differently from situation to situation. Okay, so it's good that we stick to one big method and we just follow that because it's a 5-mark question. Okay, acha, theta must be between 0 and 180. So it cannot be 3 or 5 degrees. It cannot be 234.7 degrees. It cannot be 360 degrees. And there's no point in writing 180 degrees twice. So finally, theta is going to be 0 degrees. It would be 54.7 degrees. It would be 125 degrees because you need to give the final answer correct to 3 significant figures. Okay, and it is 180 degrees. So this is going to be your answer. Yes, Motasam and all the other students. Anything that you were not able to understand at this point?
Promise.
You can
No, miss,
ask me
everything's
right
clear.
now because this is the beginning of this, right?
Miss, can you go to the previous question?
Yes, definitely.
I just want to ask something.
This question?
Miss, I think no, not this one, not this one. I think not the first one. I think the first one that we did.
The first question, this one.
Yeah, this one.
Hmm?
No, yeah, this one. Miss, I saw that here, like at the beginning, fx is equal to 3 cos square x minus 2 sin square x. Miss, after that, I think you change sin to
Yes.
cos. So I don't know what's the rule here.
Yeah, I'll tell you. Okay. So basically, other than solving trigonometric equations, you need to prove trigonometric identities. Okay. So this is what we had in the beginning, and you were supposed to write this thing in this form. And in this form, I only have cos squared x. So I have used this helping identity. Okay. These are helping identities. The helping identity says sine squared x plus cos squared x equals 1. So if I want to write this sine squared x in terms of cos x, I can write it down this way using the helping identity. I've made sine squared x the subject, okay? And then I've just plugged in sine squared x. This gave me 1 minus cos squared x, and upon simplification, I got the desired form, okay? I got the desired form. This is what I got.
Oh, okay. Thank you, Miss.
Yes, so you would have to use these helping identities according to the situation, okay?
Miss, is there anything else than this help method? Like, or it is only this one?
Anything else as in the helping identities?
Yeah,
Yeah,
like if there's anything else.
there's just one other. There's another one. Tan theta is equal to sine theta divided by cos theta. Now, if somewhere you get to see sine squared theta divided by cos squared theta, just know that this is automatically going to be tan squared theta, right? So you're only supposed to memorize 1 and 2 for AS. For A2, we have some other, but we're not talking about A2, we're talking about AS. So for AS, only these two. And obviously, he's not going to give you a question in which you would directly get to use this. You would have to play with these identities as well. For example, tan is equal to sine by cos. So if you have sine squared by cos squared, just know that it would be equal to tan squared theta, okay? Yes, is it okay?
Yeah, miss.
Okay.
Miss,
Yes.
can you send the paper numbers and everything after this class?
Yeah, this thing basically, like this one, this file.
Yes, miss. Miss, and the paper variants,
Yeah, they're stated
miss,
over
like
here.
miss, for the B part 1, I cannot find it from the same paper. 12 October, November 19.
Acha, okay, wait 1 second. Stay here. Let me see again, okay? Because I take screenshots from my phone. B part is this one. Like it's, I'll write it down here. It's 9709/12/October November /19. This is the part. I'll just take a screenshot of the entire thing and I'm sending it to you directly, okay?
Okay, miss. Miss, I understood how that tan theta is equal to sine theta divided by cos theta. Miss, it's like you draw a triangle.
Yes.
The opposite one is sine
Mhm.
theta and the adjacent one is cos theta. And then we use the formula of tan, opposite divided by adjacent. And then instead of writing opposite divided adjacent, we write sine theta
Yes.
divided by.
Very good.
Miss, what about sine squared x plus cos square x is equal to 1?
Yeah, basically it's okay. So wait 1 second. Let me just send that thing to you first. So I have two numbers for the same name.
Miss, at the end of the class, can I ask you something about the timings because of the school is coming? So,
Yes, definitely, definitely. Just give me 1 second.
okay.
I'm just taking out this proof and I'll send this to you directly, okay? Just give me 1 minute.
Okay.
This was in the book. And it is coming from the same idea, like the idea that you need to make the right angle triangle and then you would get to see that.
Okay, miss.
Wait, let me stop the recording now.